So, yeah, guys, very good afternoon to one and all. And yes, I guess it's 2 days, I guess, completed na. And today's class we are going to concentrate on this ray optics. Okay, with that very short answer questions, and the people are joining over here. Let's wait for 30 seconds. Okay, let's wait for 30 seconds. Yes, so in this topic now we are going to concentrate on how many questions, right? Like it's a 12 questions only 12 questions, like very short answer questions in array optics, like the optical instruments. Okay, optical instruments. So yes, let's join the let's start the class. Okay, I guess the people are joining, and let them join and we'll start the class over. So the first question of this class is, what are the laws of reflection through curved mirror? What are the laws of reflection through curved mirror? So the first question, if you see here, what are the laws they are asking? So totally the two laws are there, no, two laws. So one law, if you talk about, if I take, it's the thing na, like a curved mirror. Well, let me take this, a curved mirror. So angle of reflection is equal to angle of incident. So the reflection and the incident they are telling. Okay, and what about the next one? The incident ray, reflected ray and the normal. Incident ray, reflected ray and the normal. This is nothing but the normal, no? So this is my incident, this is my reflection, and this is my normal. So incident ray, reflected ray and the normal to the surface, reflecting surface at a point of incidence lies in the same plane. So that's the first one, the first question, the law of reflection through the curved mirror. Okay, curved mirror. So what about the next question? A concave mirror of a focal length. Okay, let me write the thing. Focal length, how much focal length is? F is equals to 10 centimeter. Fine, F is equals to 10 centimeter, is placed at a distance 35 centimeter from the wall. So 35 centimeter from the wall they are telling. Okay, and if you talk about the from the wall, no, it's a image distance or object distance. Okay, wait, let me take, is placed at the 35 centimeter from the wall. How far from the wall should an object be placed? So object, so this is image 35 centimeter. Okay, 35 centimeter. So object I need to find, which is nothing but u. I need to find it. I need to find the value of u, right? So to be placed so that its real image formed on the wall is, so real image. So what is the formula? 1 by f is equals to 1 by u plus 1 by v. What is f? F is nothing but a focal length. Focal length. What about u? It's a object distance. What about v? V is nothing but image distance. Okay, this is the three things. And now what is the thing I need to find? I need to find the u value, that is object distance value I need to find. No, so 1 by how much? 10 centimeter minus, I can take the minus this side, 1 by 35 will be equals to 1 by u. So if I cross multiply 35 minus 10 divided by 35 times 10 should be equals to 1 by u, and I can take to the numerator, u will be equals to 35 into 10 divided by 25. So this is 5 times and this is how much? 7 times, right? 1 times and this is 2 times. How much it is? 14 centimeter. But what's the thing we want? So this is how much? The place that is 35 centimeter. No, place at 35 centimeter from the wall, which is nothing but it's a minus 14 centimeter. And what's the thing they are asking? How far object should be placed so that the real image is formed. So real image is formed in the sense 35 minus how much it is? 14 centimeter will be 21 centimeter. So the distance between the wall and the object is 20 centimeter, and The object distance is 14 centimeter. This is the second question. You can take a note of this first question and second question, and we can go for the next questions. Okay. Got it? Okay. The next question. So if you see the next question, no, what is the thing they are asking? The thing they are asking is a concave mirror produced an image of a long vertical pin. They are saying. Okay, long vertical pin placed 40 centimeter from the mirror. At the position of the object. Okay. So here they are saying is u is equals to v. From the mirror they are telling, so will be equals to that minus times I need to take minus 40 centimeter. That the position, find the focal length of the mirror. So 1 by f is equals to 1 by u plus 1 by v. Right now. So when I talk about the minus symbols now, 1 by minus u plus 1 by minus v, like the things, no. So what is the thing I can say here? So if I cross multiply the things and if I take the minus out, yes, obviously I'll get the same thing. 1 by 40 plus 1 by 40 will be equals to 2 by 20, so 2 by 40, f is equals to 20 centimeter. That's it. F is equals to 20 centimeter. So this is the answer for this question. F is equals to 20 centimeter. Got it? Okay. So what is the optical density and how it is different from the mass density? So optical density is nothing but the ratio of the speed of light. In two media. And refractive index is the measure of optical density. Okay, refractive index is the measure of optical density. What is the thing? Mass density. Mass density of a substance is the mass per unit volume. Mass density is nothing but mass per unit volume. And optical density, what we are talking, it's the ratio of the speed of a two light in a media. Okay, in a medium we are talking. And it is a physical property of the substance. So next question is, what do you understand by the term focus and the principal focus? The two different terms, focus and the principal focus, in a context of lenses. So when you talk about a focus of a lens is any point through which rays of light are converged, and principal focus is nothing but it is a point on a principal axis of a lens at which image in the object at infinity is formed, and a lens will have two focal point on either side. Okay, so there is the third, fourth and fifth questions. You can take a note of this and we can go for the next set of questions. Okay, done. So the next set of questions, if we see, define focal length and a radius of curvature of a concave lens. So radius of curvature is nothing but it's the radius of the spherical thing. And focal length of a concave lens is distance between the optical center and the principal focus. Optical center and the principal focus. And radius of curvature of a concave lens is the radius of the sphere. That's the thing we have talked. It's a radius of the sphere and it is the distance between the optical center and the focal point, that is a principal focus. Okay, and define power of a convex lens. What is its unit? Power is nothing but it's the reciprocal of the focus. Okay, so if you talk about the power of a convex lens is defined as the tangent of an angle by which a lens converges a beam of light falling at a unit distance from the optical center, or it's a reciprocal of a focal length. So focal length, what is the formula? 1 by f is equals to 1 by u plus 1 by v, right? So 1 by u, that is 1 by objective distance plus 1 by image distance. We are getting now, that is the like a power formula, like a reciprocal of the focal length. Okay, and SI unit is diopter. And what about the 8th question, like focal length of a concave lens? Wait, let me solve this question. A focal length of a concave lens is 30 centimeter. Okay, 30 centimeter. How much of focal length? F is equals to 30 centimeter. Where should an object be placed? And so that its distance image is 1/10. Distance image is 1/10 of its size, which means focal length they have given and 1/10 they are telling now, 1/10, which is nothing but v is equals to u times of 1/10, which is v by u is equals to 1 by 10. V by u is equals to 1 by 10, right now? So what I should take? I should take v in terms of u only. U I need to find it, right? So 1 by f is equals to 1 by v minus 1 by u. Got it? So f, it is concave they are talking now, so minus 30 centimeter, and we get u as 270 centimeter, that is minus 270 centimeter. Okay, and what about the 9th question? A small angle of prism that is 4 degree deviates a ray through 2.48 degree. Find the refractive index of the prism. Refractive index they are asking. So angle of prism is 4 degree, angle of deviation is 2.48, and the refractive index I need to find, that is mu. Okay, so d is equals to mu times a times of mu minus 1. So what is mu? So d by a plus 1. So 2.48 by 4 plus 1, which gives, this is 1 times, and this is how much? And this is 6 and this is 2, 0.62 and 1.62. 1.62 is the refractive index, that's it. So 10th question is, what is the dispersion and which color gets refractively more dispersed? Okay, so dispersion is nothing but, it is not depression, it's a dispersion. Okay, so dispersion is nothing but the phenomenon of a splitting of white light. So dispersing of light, like a scattering will tell na. So dispersion of white light into a constituent color is known as dispersion, and violet color is the refractively more dispersed. Violet color is the refractively more dispersed. And what is myopia and how it can be corrected? So myopia and hypermetropia, these are the two symptoms we can talk about in the lens. Right now, when ray optics chapter is there, we are going to talk about this two. This is right now. So light from a distance, object converge at a point in front of retina. So the distance object is not clearly visible. So distance object is not clearly visible in the sense it's a myopia. Obviously the opposite. So if you talk about the near objects are not clearly visible is nothing but hypermetropia. Hypermetropia. And how it can be corrected? So myopia is corrected by using a spectacles having a divergent lens, and it is a convergent lens. I need to get it. Divergent lens, like I need to go for the far thing, like I need to diverge it. So I need to see the near thing, I need to converge everything to the one point. Okay, these are the two things, like myopia and hypermetropia. Okay, you can take a note of this and we can end up the classes. Okay guys, so with this I'll end up the class of the today's session, and we'll concentrate on the next upcoming chapter in the next session. Okay, so thank you guys, we'll meet in the next class. Okay.